Welcome to the session on the built environment. Yeah, thank you. We have a phenomenal session here today. We've got some amazing speakers. As you all probably know, the built environment accounts for a considerable amount of the emissions that we emit as a human species. It's 3.5 gigatons for site emissions. That's the emissions that come just on the site. But if you dial that back and look at source emissions, so all the electrons and the energy or the emissions that are associated with those and the embodied carbon, it actually gets up to 20 gigatons, which is 40% of total anthropogenic emissions. It's a huge number. Buildings are also a little unique amongst all of the sectors we cover in that we have a lot of technologies that are ready to go today or nearly ready to go that don't have a green premium. It's really unique. I mean, you think about fusion is not there, fuels are not there. Eric gave a really eloquent speech on that today. Hydrogen has still got a little ways to go. We need innovation in buildings, but what we really need are leaders. And so today, you're going to hear from a set of exceptional leaders in the built environment, both leaders in innovation and leaders in industry. And so our first speaker, I'd like to invite Barbara Humpton. Barbara is the, yeah, please. Yeah. All right, so Barbara is the CEO and the president of Siemens USA. You probably think about Siemens as a technology company, but in fact, they are a huge global tenant and building owner and operator, and they've made some serious commitments to getting to zero for their building footprint. So please.
Let me take you there. There's nothing I need to do, right? Yes. Okay. You can hear me. Hey, listen, Siemens. Think about this amazing powerhouse that has existed for over 175 years. Last year at our global leaders meeting, our CEO, Roland Busch, stood up and said, when the world changes, Siemens changes. And I said to him, we need to think about this a little bit differently, and this is what I want to share with you. When the world needs changing, we change the world. And so Siemens, yeah, oh, that's an applause line, thank you. So in 2015, Siemens was the first large industrial company to commit to be carbon neutral by 2030. And by 2020, we had abated about 50% of our carbon emissions. Now comes the hard part. And it turns out that in order to be successful at this stage, we really needed to work within a network. And that's where Breakthrough Energy comes in. We are so proud to be a partner, to be working as both a funder, as a customer, and also as a supplier. And I want to break this down for you a little bit. Luxwall, and I know several of us will be talking about Luxwall because here is one of those ideal stories. It turns out that Luxwall is making architectural glass that can save 45% more energy. And interesting, Christian Franz is here, our head of Siemens Real Estate, managing all these projects. Yes, come see him afterwards. Christian says that the cool thing about this is that when it was time to make the business case for including Luxwall in some of our projects, the business case was easy. Typical paybacks are two-digit years in return. Luxwall paid back in 8 years. So we know that we can make sustainability the more attractive option. Think about hedonistic sustainability, a term I learned recently. How can we make this so attractive that this is what everyone wants to be involved in? Now, the second question I have for you today is, where's the edge? Where does the building end and the grid begin? We've got other speakers talking about electricity, but at Siemens, we're very, very focused on not only our own built environment, but how we interact with the grid. And not just for us, we're also providers of electrical switchgear and other technologies to the world of medium and low voltage. And so here's a great opportunity for collaboration here, too. But none of that is made possible these days without software. So think about the way you, as an innovator, are planning your future. And I want to ask you now to think about software first. Think about the opportunity to model before you build. Think about the opportunity to try multiple configurations and permutations. Think about the opportunity to simulate with a physics-based model before you ever bend metal or pour concrete. We at Siemens are committed to all of that. So for our footprint, for our customers, our handprint, we're committed to transforming the built environment. But now what I'd like to do is introduce you to the Honorable Rachel Jacobson. She is the Chief Sustainability Officer and also Assistant Secretary of the Army. And I want to tell you that as of this morning, she certainly knows I am her #1 fan.
Wow. Well, you know what? It's mutual. Barbara's my new best friend. Thank you all so much. It's a pleasure to be here. I'm a lawyer, and so I can't speak without a piece of paper. I apologize for that, so you'll have to just bear with me. As you've heard today, if you heard John Podesta speak, climate change is a huge goal and a huge priority for the Biden administration, which has set a goal to reach net zero emissions overall by 2050. And for federal buildings, the White House is aiming for zero emissions by 2045 with a 50% reduction in emissions by 2032. Those goals are reinforced in Army's first ever climate strategy, which we issued back in February of 2022. And it primarily has 3 lines of effort. Number 1, installations and resilience, which I'm going to focus on here, but it also includes acquisitions and logistics, because our logistics tail is incredibly important in this space, as well as training. We have to make sure our soldiers understand the why and the how of this. I must also say, to level set, that everything we do with respect to climate change is about mission, readiness, and resilience. That is why we do it. As the Army works to meet those goals, we have to focus on our biggest source of emissions, which is our buildings. According to a 2022 Congressional Budget Office report, the Army is responsible for maintaining over 500,000 pieces of real property assets across the world. That's pretty daunting. And of those, that includes 200,000 buildings consisting of 1.3 billion square feet. And this is more buildings than the Air Force and the Navy combined. And we have the most buildings of any agency in the federal government. Plus, on top of that, we have about 80,000 family houses on our U.S. installations that are managed by third-party contractors, but they're still on our installations. And we manage all the family housing on our bases overseas. So that's a lot. And while fuel is the greatest source of greenhouse gas emissions for the Air Force and the Navy, if someone could crack the code on jet fuel, the DOD emissions would go way down. But until then, the biggest source for Army and, Air Force and Navy is fuel. For us, our biggest source of greenhouse gas emissions is our buildings. And that's why we issued the first ever Army Resilient Building Policy, which includes the following elements. Number 1, incorporate integrated design and passive design elements into the building project to reduce water and energy use intensity. Do it from the beginning. It has to be in the design. Integrate carbon-free generation and storage, which we're doing on our installations in a really big way right now. It's part of the federal government to electrify all buildings. We are also performing deep energy retrofits on many of our installations. We're working with utilities to assess the grid capacity, because as we do all of this electrification, we have to be mindful of our defense communities, and if we use too much power on the grid, that takes power away from our defense community. So this has to be a partnership. We're also focused on demand and consumption. We offer incentives to installations that reduce their utility bills. They get to take part of those cost savings and use them on the installations for recreational and other purposes. We are also, as far as this conference is concerned, part of our resilient building strategy is use lower embodied emissions building materials as the primary construction material. So it is really wonderful to engage here during this conference with so many of the innovators who are advancing those kinds of materials that are going to be so useful to us as we go forward. So it's so beneficial. Another element is incorporate natural infrastructure into the building design to promote energy and water efficiency. And we need to do more of this. Engineering with nature really needs to be part of the decarbonization solution. It really does, including in the built environment. There's a room for it there. We're also going to perform a whole building life cycle cost analysis to really understand not just component by component basis, but overall. And we're doing a couple of these projects already. We're building a barracks building at Joint Base Lewis McChord in Washington State out of a low carbon concrete. The material is Portland limestone cement that has 30% less carbon than conventional concrete. And we're also using recycled steel. Interestingly, that project was directed by Congress in the 2022 Defense Authorization Bill. They didn't dictate where it should be, but they said do a pilot project with low carbon materials, believe it or not. And next year, also at Joint Base Lewis McChord, we're going to do a building out of mass timber for the same reasons. And our partner here, a key partner, is the U.S. Army Research and Development Center, ERDIC. Has anybody in this room worked with ERDIC? What? Oh, good. They are such a premier research organization. And right now they're doing cutting edge research on sustainable building materials. So you really should work with them. Data from these projects is going to be so valuable because I can't say enough about the need for good and reliable data that will help drive policies and inform decision makers going forward. So that's just a brief overview of what we're doing at the Army. I look forward to our conversation.
Just stay for a second.
Oh.
Yeah, so just awesome. First question, lightning round. What keeps you guys up at night about this monumental task ahead of us for decarbonizing?
I will tell you, stovepipes and silos. Stovepipes and silos. This isn't a technical problem. This is a people problem.
Mm-hmm.
I will pick up right where I left off. Data. For Army, our data, let's just say, is not consistent the way we collect data is not consistent from installation to installation. We don't even have a handle on our baseline. So how are we going to know how we're improving if we don't really understand what we have? So data and the need to make sure we have good, reliable, usable data, that is what keeps me up at night.
That's a good segue from the last session. AI, I think, right?
Yeah.
Anyway, so other question, and you've already sort of blown my mind, 200,000 buildings, but if there's one thing about your organization that would surprise this room that they should know, what would you say that is?
Well, I think what people don't realize is that the military has long recognized that climate change poses a national security threat. And as early as 1991, the George H.W. Bush administration included in that administration's national security strategy a finding that climate change is a national security threat. And that finding has found its way, one way or another, into every single subsequent national security strategy. It's been called a threat multiplier, and we have to get after it. So this is something I think people don't know, is that's why we're focused on this so much.
Hey, and then I would tell you that we're trying to use every muscle we've got. In 2022, when we needed to write a new lease for our headquarters in Washington, D.C., I asked the team, would the landlord go on the zero carbon journey with us? The answer from the landlord was no. So we moved.
Nice.
Everybody, my name is Cooper Rinzler. I'm a partner at Breakthrough Energy Ventures. Psyched to talk to you today. I love the built environment. I've been referred to as indoorsy. So here we are. Here we are. So emissions in the built environment, they come from the energy and materials that go into making buildings, that we call that embodied carbon, and then it comes from the operations of operating building once it's built. So let's talk about embodied carbon. The king here is obviously steel and cement. Those are the two big materials that literally are the foundation of our civilization, the literal foundation. And let's talk about steel first. You know, steel's amazing. It comprises more than 90% of all of our metals use on the planet. And that means it's almost 2 billion tons per year of steel that we use. We use so much because it's an incredible material. It's formable, castable, weldable, super tough, super strong, super durable, and most importantly, it is cheap. In fact, on a performance to cost ratio, it's hard to find any material that beats it. So we use a lot of steel because it's amazing. Unfortunately, as you all know, it comes with a lot of emissions. In particular, it's nearly 2 tons of CO2 per ton of steel, maybe more depending on the way that you're making it. That means it's a real grand challenge. So there's 6 ways to think about decarbonizing steel. The first is you could consider using something else. That's very hard for the reasons mentioned before, but it's possible, you know, thinking about aluminum frames in the automotive industry, et cetera. But steel is so unique that we're never gonna get to zero on steel. There's no chance, it's too good of a material. The second thing you can do is extend the use of steel. So we can make sure that we're doing all of this recycling that we can. Steel is immensely recyclable. However, we already recycle most of it. So there's not a whole lot more room to go there, but there's some possibility there still we should keep in mind. The third thing you can think about doing is decarbonizing the energy that goes into steel making. Unfortunately, and you probably know this, steel is one of those annoying things where there's this thing called process emissions. The way that we make steel today is the same way we've made steel for about 3,000 years, which is that we take carbon and we combine it with iron ore to rip off the oxygen and make steel. And so even if you decarbonize energy that goes into steel making, without decarbonizing the reducing agent, that process emissions of the carbon, it's really hard to make progress. That leads us to the fourth, which is finding a different reducing agent other than carbon to decarbonize steel, but using that in existing processes. Hydrogen is the one that's most talked about, hydrogen DRI. That's a great solution that might have some added costs, but a great solution. Or potentially using bio-based carbon materials in conventional steel making, which has been incorporated by industry today. The fifth way is CCS. That's a pure cost adder, obviously, CapEx intensive, OpEx intensive, energy intensive, but possible in the space. It's a relatively concentrated stream of CO2. And then the last is novel ways of thinking about making steel in the first place, novel reduction methods. And that's really where I think we have a lot of promise. So here to talk about a novel way to go about reducing iron ore and making steel is Tadeu Carneiro, my friend, if you wouldn't mind coming up. Tadeu is my friend. He's an extraordinary human being. He's an absolute king in the metallurgical community. And prior to becoming CEO of Boston Metal, Tadeu was CEO of a company called CBMM, which is the global market leader for niobium production, a ferroalloy, where he built that business into a multiple tens of billions of dollar value business. We're so thrilled to have him in this space. Tadeu, please.
Thank you, Cooper. Thank you. Cooper was going very well until he started to talk about me. So everything that he said until he started to talk about me, that's a fantastic thing. So what else can I add to steel after you made that fantastic summary? I'm a metals veteran. I worked with metals my whole professional life. And I look like 85, but I'm actually 120 years old. So it's I've seen steel for a long time now, and we are developing a new way to manufacture steels, writing the new book in steel metallurgy, which involves the use of electricity. So you substitute electrons for the carbon in the equation in a very simple one-step process. So you add iron ore of any type in a cell, pass electricity, get your iron for your steel in the liquid form, and emit oxygen. So that's what, in a nutshell, the process is. So any iron ore doesn't need to be premium iron ore. And as a matter of fact, as we go forward, we can transform tailings of iron ore production into mines, because the process, what's in there, other than the residual iron ore are actually the components of the electrolyte in our cells for the process. So we can use any iron ore, electricity passes one step, and you get your metal in the liquid form. Whoever visited a steel making facility and had any education on steel knows that steel needs to be liquid. You know, this business of thinking of steel in the solid form, you know, doesn't make it. I mean, steel is a very sophisticated material. You need to have it in the liquid form. And then you go to level metallurgy, corrects the composition, because you have hundreds of grades of different steels. It's very sophisticated material. 60% is long products, yeah. The great majority is rebar and stuff, but 40% is flat products, all sorts of different grades. So it needs to be liquid, always. Then you correct the composition, send to a caster, and go to the rolling mill. So you can't get around that. But the big portion of the emissions happens until you get the first form of liquid steel. And that's where our process will revolutionize the industry. So we get iron ore. You doesn't need to process the iron ore. You add it in the cell, if it's fines or lumps or chunks or whatever, gets dissolved in the electrolyte. The cell works where the steel is liquid, in the liquid form. You collect in the bottom of the cell. Once you have enough, you tap the cell, and everything else is the same from that point onwards. So it is a platform technology. We can use the same technology to extract value from mineral waste. In that case, we can use off-the-shelf anodes for the cell that allow us to deploy this technology industrially right away. We started to do that. Our first plant is in Brazil, and we will extract value from slags and mineral wastes that represent an environmental liability now, in a very clean way. So that's what we are doing. Very excited, and I want to thank BV for inviting us and letting us participate and talk about our journey here with you. Thank you.
It is amazing to see some real reason for hope in something as tough to decarbonize as steel. All right, let's talk about the other big kahuna, cement. So some of you might know this, but in 2020, the world hit a new milestone, which is that there's more anthropogenic mass on the planet than biomass. We did it! Yeah. And most of that's concrete, right? We do about 40 billion tons per year of concrete. Holy crap, it's an amazing material. The miracle ingredient inside this miracle material is cement. It's the glue that holds together the rocks, the gravel, the sand, et cetera, that make up concrete. And specifically, ordinary Portland cement. That's the super majority of what's used today, right? Of course. And cement's amazing. Unfortunately, as you know, it comes with some emissions. So between about 2/3 and 1 ton of CO2 per ton of cement. And what's really specifically and uniquely problematic about cement is that only 1/3 of those emissions actually comes from the energy use that goes into making cement. 2/3 comes from the very chemistry. Today we make ordinary Portland cement by starting with limestone, which is literally calcium oxide plus CO2. And the first thing we do, we boil off that CO2. And then we blend the remaining ingredients together, make clinker, make cement. Yay, you've seen billions and billions of tons of this stuff. But because that CO2 is literally intrinsic to the process emissions of the process, energy decarbonation is insufficient. So there are 5 ways to think about decarbonizing cement. I'm trying to channel tune up here, bringing that energy. 5 ways to decarbonize cement. First thing you can do is have an alternative material, right? So you could consider using something else. You mentioned using timber, for example, right? Or novel combinations of new cement materials, right? There's great reason to think that there's promise in alternative materials. However, we use a lot of OPC today for a reason. It's a magical material at low cost. And so there are going to be some applications that are probably going to be recalcitrant, but alternative material systems, whether novel cement chemistries or other materials, is possible. The second, extending the use of cement. There's a lot of interesting opportunities. We'll talk about one shortly. But this is basically, concrete's the thing we actually use as a building material, not cement. And so if you can use less cement per unit concrete, you can decarbonize a portion of your concrete. And you can do that by making the cement harder, or by using something called a supplementary cementitious material, or doing some mixed design. So extending the use of cement is a real viable solution that also tends to be cost negative, which is great. The third bucket is you can decarbonize the energy in cement. We should absolutely try and do that, but again, that's only 1/3 of the emissions. And then you can do CCS, of course. Cement has the wonderful distinction of being the highest emissions per dollar value product that we make. Sometimes it's higher than oil, which is insane to think about. That, of course, means the green premium for doing something like CCS is significant, something like 100%. So that's challenging, but possible. And then the last thing you can think about doing is making the same exact material that you're making today, but with an alternative feedstock. So instead of using limestone as the source of that calcium, can you use another source of calcium, like silicates in the crust? Avoid the CO2 in the first place, no more process emissions. So I'm really excited here to talk about an incredible innovation in the extension category is Donal. Please join me up. Donal is a hero in the cement space. I think you left Big Cement 2 decades ago or so, maybe a little bit more. Yeah, we won't try and age you. Okay, that's great. 25 years ago, right? And to build Ecosem. And Ecosem is working on a solution that we are deeply excited about to very rapidly, and with little to no green premium, if maybe even negative, rapidly decarbonize a huge chunk of emissions. Thanks, Donal.
Thank you, Cooper, and good afternoon, everybody. Cooper counted to 5 when he gave you solutions. Well, I have a 6th one that I want to add on, which is the efficiency with which we use cementitious materials. Unfortunately, over 200 years, the way we make and use cement hasn't changed, and the result is that we're stuck with systems that extract only a small portion of the performance potential of cement when it's used in practice. So the first big lever that we need to get our hands on straight away and operate straight away is to extract maximum performance from cement. When we do that, we see that we can double the performance of cement, conventional cement, which means immediately that we can use half the cement we use at the moment for the same effect. So we've saved half the CO2 emissions from the cement industry, which happens to be 3.5% of global CO2 emissions. The second thing is that we can then, because we're using cementitious materials more efficiently, we can make greater use of the low carbon constituents of cement. We can boost their makeup of the cement and reduce the use of the high carbon elements. And when we do that, we go from 50% reduction of the carbon footprint of the cement industry globally to a 70% reduction of the carbon footprint. Now, my company, Ecosem, we delivered our first product in 2002, so we're like 22 years building up a profitable and sturdy business. We've been through 4 different iterations of low-carbon cement technology. We started with the simplest and the most traditional, which was underutilized at the time, but no longer is the case. So that was a good business model for 10 years or so. But we realized at the end of that if we wanted to develop our business, we had to be able to innovate, and we've invested heavily in building up the largest concentration of high-level talent in the high-efficiency use of cementitious materials that exists in the world today. 1 in 5 people who work for us works in our research and development department. We have 40 people full-time, supported by 20 international experts around universities all over the world. So we have been seriously investing. The rest of the cement industry has ignored the potential of high performance, and as a result, we're the global leader in this technology. So what can we do with this technology, and what are the risks? I hear you asking, well, if it's all that good, does it perform? How well does it perform? And how much does it cost, et cetera, et cetera? Well, you judge this performance of cement on its strength, its durability, and of course, its price. On strength, it's higher strength. On durability, it lasts longer. On price, no difference, no green premium. This is competitive with the existing cement that we buy every day to build our infrastructure and housing and so on. So this is a technology now that has been recognized by, there is a European standard introduced at the end of last year, which allows this cement to be sold everywhere in Europe. And our first product has been certified as in conformity with that standard, and that's our first product, our first ACT product, ACT product as we call it. So what are we going to do from this position? Well, everything isn't solved because we now have to start the scalability journey. I used the phrase before, maybe some of you have listened to me talk about this before me, has heard me use the phrase about traversing the valley of death in terms of bringing in new technology. Well, we've successfully done that, and now we face the Everest of scalability. And it's a real challenge, and there are many things we have to do, and among them are, first of all, the industry has to respond. We as a company produce just over 2% of the cement in Europe. So even if we expand very rapidly to 5 or even 10%, we can hardly make a difference at European level, never mind at global level. So we have to speak, this message must go out loudly and clearly to the industry. They are expected to respond. That's the first question. The second question, are policymakers, whether in Europe, at Brussels, or in the Department of Energy in the States, are 10 years behind the technology now. This technology has moved forward very, very fast and very, very credibly. The policy needs to change. And above all, the fixation with carbon capture and storage needs to end. It's a non-solution. It's priced out of the market in terms of anything that any one sensible person would spend money on. And in fact, it's simply unaffordable in 3/4 of the world. Secondly, even if the EU and the States get together to be virtuous and work miracles in this area, they represent 7% of the CO2 emissions from cement manufacture in the world. The problem isn't to decarbonize Europe and the States, it's the rest of the world that is the real challenge. We need to look at active policy to support technology transfer and training so this technology can move as fast as possible into areas such as Africa and the Indian subcontinent and so on. Finally, some of the people that are represented here today, we're all stakeholders, in effect. We're all partners, whether we like it or not, in this journey. We need to learn to work effectively together. This technology will be in the market in 2026, but only in 3 or 4 Western European countries. We need to be able to do much more than that. Our ability to work with established developers and established construction companies has been very positive and very helpful in getting where we are today. We need to do much more of that. What's at stake here? If we're successful with this technology, cement production, which is 1/4 of all industrial CO2 emissions, cement can decarbonize on a trajectory consistent with 1.5 degrees of global warming. So this is a big deal, and we have to get very serious about it. I said one last comment. I said we could decarbonize 70% of the cement industry. So I hear you ask, what about the other 30%? Well, the other percent, we're working on it, the other 30%. Myself and others, I have to say, there are other brilliant and excellent people who are working as well, more and more people working in this space. I am personally convinced that before the end of this decade, we'll have a full palette of solutions that will enable us to decarbonize cement rapidly without recourse to carbon capture and storage. Thank you for your attention.
All right. I love this audience. We're getting amped about cement and steel. Let's go. Okay, let's one quick question, less than a minute each, right? This is a doozy. Let's go Tadeu first. How do you think about the green premium for steel? And what do you think needs to be true as innovators for us to get the green premium too for green steel to actually scale?
Well, look, you did well when you said that this steel is being manufactured for 3,000 years the same way. So if you think that the first industrial demonstration is going to beat 3,000 years of development, think again, right? So getting to revolutionize the steel industry means that you have to revolutionize the whole supply chain. So there's a lot that needs to be done in order to get to, and we have a journey to get there, to get a capex that is $1,000 per ton. which is less than the incumbent today. It is possible, right? And on the operational expenses, you don't need to have a premium with our technology, really. So we can use any iron ore. Once we get to the mature technology using around 4 megawatt hours per ton of steel, which is energetically efficient compared to the incumbents that today uses 5.5 to 6, and the electricity price is $40 per megawatt or less, you are competitive with the current cost of steel without a carbon premium. So there is a journey, it is possible, doesn't it? Our technology can deliver that. Any iron ore, don't need to have a premium there, and it's a question of getting the efficiencies. Just one more data to substantiate that. You need, I am considering in the 4 to 5, if you say, megawatt hours per ton of steel, twice the amount of energy that you need to break the bonds of the iron oxide. So you can have 100% of losses and still be competitive without a carbon tax. It's possible.
Thank you, Tadeu. Donal, same question for cement. How do you think about the green premium for cement and what needs to be true for adoption?
I think we should forget about the green premium for cement. It's just simply not technically a necessity whatsoever. Operationally, we don't have financial barriers. We don't have technical barriers. The only barriers is our willingness to organize, to do things quickly and at scale and on a fast track. And to start the process, I would like to make an offer to the US Army to consult with them on their new technology so they can go from 30% reduction to 70% reduction in all the cement and concrete they use.
This is Shark Tank. And just to touch up on that, what about for that last 30%?
Yeah, the last 30%, if you look, the way we analyze it is as follows. We have 70% in the bag without any premium. Of the remaining 30%, we reckon we already know how to get half that out without any premium. And my guess is the rest will go the same way before the end of the decade.
Awesome. Thank you so much, gentlemen.
Thank you.
Appreciate it. All right, well, that's done, solved, right? No big deal. Okay, well, once we've built the building, these pesky humans have a habit of inhabiting them. And actually, when you look at the life cycle emissions of the built environment, most of those emissions come in that operational phase. Most of those emissions are, of course, from energy. And you know what the biggest energy contributor is. It's heating and cooling. We're kind of feeling it right now, aren't we? And you know what's amazing, we've made a lot of investments in the heating and cooling space, in building envelope like Luxwall and AeroSeal to help with building efficiency, with building control. And what's really amazing about the space, Brian mentioned at the beginning, is that there already are solutions that are cost negative today. Heat pumps are here. They're real. They're one of the most cost negative transitions that we can make today, even more than EVs, believe it or not. And on par with renewables. But there's still a lot of work to be done in innovation to help expand the rate at which we're scaling the deployment of heat pumps. Here to talk about an amazing vision of how to accelerate the transition to the existing clean solutions that we have in the built environment is Marisa Reddy. Join me up. Marisa founded Conduit out of Stanford. You were in the Fellows program, weren't you? How about that? A Fellows program that then became a Ventures portfolio company. And I challenge you to find anyone who's more passionate about HVAC than Marisa.
Thank you so much, Cooper. I am indeed very, very passionate about HVAC. And when you think about the building retrofit space, half of the equation, of course, is inventing and manufacturing the amazing breakthrough technologies to decarbonize those buildings. The other half, of course, is the mass deployment of those technologies. And that mass deployment happens through a wide, very fragmented base of installers the world over. Literally millions of sole proprietors, small, medium businesses, for the most part, a very fragmented installer base. These businesses must care day in and day out about their bottom line to survive year in and year out. This means that those businesses absolutely have to see decarbonization as quick, profitable, and easy. Conduit sells software to small, medium, and large heating and cooling contractors in the US. This is our beachhead market. We focus on residential and light commercial contractors. When we started exploring this space many years ago at this point, what we saw is that it is really, really hard for those contractors to sell heat pumps and grow their businesses. I'll paint a picture as to why this is the case. So when a contractor is walking into a residential structure, if they believe that a heat pump is the right solution for that space, there are many incremental design and sales tasks that they must engage in to actually sell a heat pump relative to a traditional AC or a fossil-fueled furnace. The first piece, of course, is the design. So they need to make sure that that heat pump, to deliver on its promise of energy efficiency, comfort, and lifetime expected value, is to actually design the refrigerant cycle for the structure of the space. This means the contractor spends several hours on site actually measuring all of the walls, windows, and doors of the space to draw a 2D floor plan and then estimate the heat transfer from the outside to the inside. This all happens by hand or using very old incumbent software that was not designed for them. It was designed for building engineers of yesteryear, unfortunately. After the design step, those contractors then need to go back to their office and put together the sales materials. Because while Cooper is indeed correct, heat pumps are a cost-negative solution, the upfront cost today is often higher than a traditional AC or a furnace. So that contractor needs to put together a cohesive narrative about the ROI of that piece of equipment to convince the building owner or the homeowner as to why they should invest in that technology. This means that they have to have an extremely clear understanding of the price impact of rebates and incentives. These are programs that change with frequency in their local markets. It also means that they have to have a very clear understanding of the differential costs of energy, also something that is very hard to predict for those installers. Frankly, this is just too much work, and all of this incremental complexity of heat pumps versus traditional furnaces or ACs is pushed onto the small, medium businesses. This is not a sustainable system, and this is not how we are going to scale heat pump technology for the decades to come. This is really the problem that Conduit is digging into. So heat pumps are hard to sell today. We want to make it easy. The core of our technology is actually a digital twin technology. So within several minutes on site, utilizing a simple LiDAR scan in consumer electronics, a contractor can get to a very solid understanding of the optimal heat pump, air distribution system, and envelope retrofits to decarbonize the space in a cost-effective and comfortable way for that homeowner. Ultimately, we help them automate the sales process to the point where it's easier than installing a fossil-fueled furnace. Our vision, the goal of the future that Conduit is working towards every single day, is that decarbonization is ultimately effortless for every installer, every retrofit technology, every single building the world over. This will take years of work. We're ready for the challenge. We're absolutely asking for the support of those in this room. If you have large residential contractors, if you're designing equipment, if you have a large residential asset base, please get in touch with us. We are absolutely excited to scale our technology with your support. Thank you.
I love it. Call to action. Okay, we have some amazing solutions already in heating and cooling, but if this room is any evidence, we could do better with cooling. And here to push the limits of efficiency of cooling ever higher is Daniel Betts. I'd like to welcome you up, please. Daniel is with Blue Frontier. He's a seasoned entrepreneur, multi-time entrepreneur, which I think translates to glutton for punishment. And I think you're here to share with us a vision of how we can globally decarbonize, but also improve the efficiency and availability of a novel cooling solution. Please.
Hello. Hi. All right. I think we can agree that I have the easiest job ever today. It's hot, and I'm selling air conditioners, so there we go. But air conditioning is actually the fastest growing use of electricity around the world. And it is also the fastest growing use of electricity in the United States. And that's a problem. Because air conditioners, this electricity that air conditioners consume is not aligned with renewable energy. So the majority of air conditioning electricity consumption occurs not at the same time when renewable energy is being produced, creating a market for the batteries, driving the cost of implementing infrastructure for renewable energy, and making it really hard for you guys to decarbonize your buildings. But air conditioning also has another huge problem, and that is that it's an extremely inefficient technology as I see it today, but it's a technology which efficiency drops as the temperature outside increases. So the conventional air conditioner gives you less when you need it the most. You guys know this because you guys pay electric bills. And so if you have buildings, you know that summertime is when you're paying a lot of money. Well, I have a good news for you. Blue Frontier has developed air conditioning technology that massively reduces the energy consumption of your buildings associated with cooling. We can create efficiency gains that are they reduce electricity consumption from 50 to more than 90%. But there's even more. The system uses a liquid desiccant, a salt solution, to store energy and to create this cooling process, which means that you can determine when and by how much you want to consume that electricity without affecting when you're going to provide air conditioning to the building. This allows you to tie the electricity consumption of your unit to renewable energy, in effect decarbonizing your building. I've just told you that I'm going to save you massive amounts of money. I'm going to decarbonize your buildings. I think it calls for celebration. But there's more. We all are feeling something in this room, which is humidity. The conventional air conditioner does a really crappy job of dealing with humidity. But it turns out that your comfort is not just determined by temperature, but by humidity. Humidity, in fact, is a major and the bigger determinant of how you feel. So, Blue Frontier's air conditioning systems directly and independently and intelligently control humidity and temperature in your building, enabling you to create environments inside your space that are unimaginable today. We are doing to air conditioning what LEDs did to lighting. We're not only reducing the energy consumption, but we're going to enable you to paint the insides of your buildings in ways that you cannot even consider today. Okay, now you can clap. So if you're interested in saving a lot of money, making people comfortable, and decarbonizing your building, I think you should be talking to me. Thank you very much.
Awesome, amazing. So we have some incredible leaders in the building space here today with us. I'm looking at Jan right now. I just happen to see you, but I know that there's dozens in the room. In 30 seconds or less, what's your vision for an HVAC future? And if you had a call to action to this audience, what would it be?
I believe that air conditioning is right at that transition that you were talking about between the grid and the building. And I would envision that for everyone to be able to have air conditioning should become part of the grid infrastructure for energy storage, load leveling, and decarbonization.
Love it. Love that answer. Yeah, let's turn it into a battery.
Yes.
Yes, I would say involve installers in your decisions. When you're designing equipment, programs, policies, make sure installers are at the center of that conversation as well.
Amazing. All right, thanks everyone. Let's applaud our entrepreneurs.
All right, so we're going to bring it home. You've heard from two major asset holders and developers. You've heard from innovators in embodied carbon. You've heard from innovators in operational carbon in the built environment. So we're going to finish off with the future of construction. So our first speaker for this last is Mei Ng. Mei is the CEO of Pan United, a major supplier of concrete in Asia. So we're also going to get a little bit of what's going on out east and on the Far East, and what are the challenges and opportunities. So thank you, Mei.
Thank you, Brian. Good afternoon, everyone. Today we have heard very promising ways to reduce operational and embodied carbon emissions. And together, they make up the whole life carbon emissions of a building, of the built environment. What is lesser known is that concrete alone accounts for 33% of the whole life carbon emissions of a typical building, and even more for an infrastructure project. So how do we reduce the carbon footprint of concrete then? You've heard some great solutions today. So the good news, like you heard today, is that there's technology. The technology is available. Now, what is important? The crucial element is the design stage, like what Jacobson was saying, right? Start from the start. Let me explain. By specifying low carbon concrete at the design stage, you can actually save 20% of the whole life carbon emissions of a building. Now that's huge, yeah? And low carbon concrete right now is already available. We replace CO2 intensive cement with supplementary cementitious material. And Penn United, we have achieved this 20% savings already for new buildings that we supply to, and even more for infrastructure projects. So let me share with you how this is possible, because there's a lot of inputs from great technology and startup companies, and there's an issue with startup. There's this issue about how to scale up, right? So let me share with you how we do this. Technology is actually giving us a whole new generation of concrete products. Carbon Cure, Rob is there, the founder, is an excellent example of a new technology that we are using. So for those not familiar, Carbon Cure technology injects CO2 into concrete, you know, and it helps us produce what we call carbon mineralized concrete, CMC. So when you use Carbon Cure technology, you actually use less cement, and without affecting the performance of the concrete. And more importantly, it stores CO2 in the concrete forever. And we have also specially formulated mixes like high strength, ultra high strength, lightweight, high density. These are special mixes which require far less concrete. So what we have is we have lighter structures, lighter buildings. So you need a smaller foundation, you need less natural resources, and lower carbon footprint. So we have the technology. Now, how do we make concrete a given at the design stage? So regulators and structural engineers, they are the key. They are the key. Because when they need to be specified, they need to be satisfied and convinced of the durability and performance of concrete. And so we have to work with them very closely. For example, for Carbon Cure, we have provided very robust testings to provide them the technical data and validation. And with the engagement, we've actually convinced them that it is a very good product, and now they're very supportive of the use of carbon mineralized concrete in Singapore. Cost. Cost is a concern for developers and owners, right? We already have evidence that sustainable design is value accretive. An international developer, they recently shared that it saved 9% in a UK project by incorporating sustainable designs, green steel in their project. And right now, they are applying these principles in Singapore for a very large development that we are providing a low carbon concrete to them. So, you know, we have the technology, we have adopters who wants to use them. So what next? What else can we do? So by working closely with the stakeholders, and in this respect, Our stakeholders, we have identified not just our employees, our customers, our regulators. It also extends to our media, to our financial institutions. We are engaging every one of them to bring up awareness, to engage them persistently, one group by one group, and that's how we are doing it. So, and the result is more than 50% of our sales is actually from low carbon concrete. And with Carbon Cure, with Rob's support, we are the global producer of Carbon Cure concrete, you know. So what else? What else can we do with concrete? With concrete, you can lower the carbon footprint of a building, of the built environment. So we have identified another way. You know, Singapore is a tropical country with an average temperature of 28 degrees. You know, it is a prime example of the urban heat island, or UHI effect. You know, the temperature is 4 to 7 degrees higher in the built-up environment. And Singapore is actually addressing this through our green plan. And we have also found that concrete, actually replacing asphalt with concrete for roads, you can bring down the air temperature by 1.5 degrees. So we have found that, you know, in conclusion, decarbonizing the built environment is an opportunity for us to innovate, collaborate, and lead. At the same time, the challenges are multiple and the pushback is high. But we have found that it's highly possible, and also it makes very good business sense. Thank you.
Thank you, May. And for our last speaker, Julia Gisewite, Chief Sustainability Officer of Turner Construction.
Thank you, Brian. Keeping you all from your next session, so I'll go ahead and be fairly brief. For those that don't know Turner, we are the largest builder in the United States. We have 11,000 employees, and we'll do $18 billion in revenue this year. We're part of the ACS global group of companies, so we have a geographic scale and reach in North America, South America, Australia, India, Asia, and Europe. In North America, we work in nearly every vertical market sector, heavily in commercial and healthcare, but most heavily in what we refer to as the advanced technology market. What I mean by that is data centers, that is industrial, that's in pharmaceuticals, and that's in chip and battery manufacturing. We have 40 offices across North America, and we recently expanded into the European data center market. We're agile for our size, meaning we develop specialized expertise very quickly to move into emerging markets, but it is our culture that keeps us resilient, and we're very authentic in our desire to actively care for people, to protect the planet, and to operate our business with authenticity and integrity. With regards to climate, very simply, we want to decarbonize buildings and the processes and the material used to build them. We are targeting net zero emissions across all of our reporting scopes by 2040. When it comes to scopes 1 and 2, our true north is a truly viable net zero construction site. We are working with OEMs, we are working with corporate partners in the room and domestic rental partners to figure out how we take and deploy highly electric construction equipment to market on our sites. And while our sites, the way we operate them and the logistics of our sites are heavily diesel intensive, we guzzle a lot of diesel to run them. The reality is that the footprint of operating buildings themselves and the emissions from our building materials, the embodied carbon, is actually much, much larger. So just for some context, Turner put in place over 1.5 million cubic yards of concrete in 2023. We placed over 400,000 metric tons of steel. So just rough numbers, that looks like 400,000 hectares of forest to sequester that much carbon. So to meet our Scope 3 ambitions and to help our clients do the same, we very clearly see that one of our missions is to decarbonize all construction materials, but in particular, concrete and steel. But the challenge is this: change and innovation in construction is really hard. We like a safe bet, particularly when it comes to our structural materials. The old way of doing things makes us notoriously slow to change because we like predictable and we like reliable. And I don't think that our risk aversion really is that surprising because we work within strict contractual frameworks, we work in tight deadlines, low profit margins, and have very narrow work in tight safety regulations. We're also very fragmented. I think someone mentioned fragmentation. We have a lot of stakeholders making decisions along the way. And while our supply chain is becoming increasingly global, there remain elements that are very, very hyper-local. So if we know that innovation in construction is an uphill battle, how in the world are we going to scale up and scale out the solutions of the innovators in the room today? Well, surprisingly, where we've actually had a lot of luck is with small and incremental and gradual change opportunities, particularly with materials. These are not necessarily materials that are wholly new and different. They might be revolutionary, but the key is that they're evolutionary. And what I mean by that is, we like materials and products that can slot into an existing process, that don't wholly change the upstream or the downstream effects of the adjacent systems that they touch, and can be used without compromise to the things that we really value in construction: cost, schedule, quality. So we've had success with products like Carbon Cure. We've used it on several data center pours for Microsoft in the United States, as well as for other clients. We used it in a cost-neutral capacity, and it allowed us to reduce embodied carbon in our concrete on those projects without making significant additional changes to the rest of the mix design. Also, LuxWall. The vacuum-insulated glass provided by LuxWall is a nice one-for-one drop-in for existing inefficient single-pane glass units, a great application for new construction, but I'm really excited about the existing building retrofit opportunities. Or renewable fuels and renewable diesels. I see those fuels as essential swap-outs until electric construction equipment is at scale. Those fuels help us build momentum now, and they can be deployed now. Because I think that's what we really need now is momentum, right? I know slow innovation sounds counterintuitive. 40% of global greenhouse gas emissions coming from built environment means that we need to be looking for sea change. But we can't look past the step of building confidence in these materials. We need many, many, many successful case studies. So use the innovations of the folks in this room. We need to push comfort zones. We need to create a willingness to try new things, because then when the next new thing comes, and the next new thing, and the next new thing after that, it feels less intimidating. And to me, that's the path towards decarbonization of construction. We make it feel more actionable and less overwhelming. Thank you.
I would have everyone stand up. If everyone would stand up who were the speaker. So at the beginning, we started with a call or need for leaders. And I hope you agree that these are all exceptional leaders in the built environment. But also, I mean, looking around this room, I see people who I know are leaders, who are, and it's a call to action. I think we need more leaders like these, more leaders like you. And I want to thank you for coming to the session. And let's thank our speakers one more time.